Good morning all.
Good morning, sir.
Am I audible to all of you?
Yes.
Okay, fine. In the last lecture, we have seen some of the examples related to. Yes, Nandini? Yes, Nandini, do you want to ask something? Fine, I think there is some misunderstanding. It's fine. Okay, up to the last lecture, we have seen many examples related to uh, method of least squares. In the method of least squares, there are two different methods. One is linear and second is non-linear, or you can say second degree parabola, or you can say a quadratic trend line. All these words are same. In short, in method of least square, there were two different types. One of the type was linear. In that case, we were likely to take an equation as y is equal to a plus bx, whereas in the second degree parabola, this equation will be in a quadratic format, or you can say it can be of a second degree parabola. When I use the word second, when I use the word second degree, that means the highest power in the equation is 2. That is why it is called a second degree. Degree is 2. That means highest power of a variable is 2. When I say highest power of a variable is 2, that means for a moment let us suppose that variable is x and the highest power is 2, so it will form x squared. So this sort of equation is called a second degree parabola. In the last lecture, we have seen some of the example and its practicality too, and we are continuing our journey with some more examples. Till now, up to the last lecture, we were trying to understand the concept. Now, our focus is on speed. Try to do it as soon as you can. Try to enhance your speed and make it happen as soon as you can. Because now the conceptual clarity is already there. So now all the example which we are going to view today, our basic focus is on speed. Because conceptually we are very clear about it, right? So let us take the challenge. The price of a commodity during 2004 to 2009 are given below. Fit a
Sir,
second degree. Yes,
do you share the slide?
slide is already there on screen.
Yes, sir, we can see.
Is there any issue regarding viewing the slide?
No, sir.
Yes, Nandini. Nandini, please speak up. I think Nandini is having certain issue with her own system. I think all of you are able to view this slide on screen right now.
Yes, sir.
Okay,
Yes,
then
sir.
let us proceed further. Uh, the data set is given to you of the data 2004 to 2009 and price of certain commodity. Okay, the thing which we require is to fit a second degree parabola. Second degree parabola means an equation should have the highest power as 2. So that equation is y is equal to a plus bx plus cx squared. Also, there is one more question given to you. Calculate the trend values and estimate the price of the commodity in 2011. So the data set given here is from 2004 to 2009, and we are likely to estimate for 2011. So you have to predict the price of 2011 on the basis of the given data set. Fine enough. What should be done? Throw some light, if in any case, if you can. What should be done in this example at an initial stage?
First, we have to arrange in a proper column.
Column format. Put it in a column form. The first column is year, second column is price. Fine enough. Rewrite it again in form of columns. The first column tag, or you can say title, is year. The second column is titled as price. Now, the first column, it is in a form of, it is titled as year. So first thing is to be done is, first of all, observe how many observations are given to you.
6.
2004, 2005, 6, 7. That means there are 6 different observations. So your capital N is 6. And 6 is an even number. So always what you will have would be 2 different years as a middle year. Which are these 2 different years?
2006 and 2007. So the
2006 and 2007 will be the 2 years which are named as middle year. Okay, from this to middle year, we have to take a mid year, mid point of this 2 years.
2006.5.
Absolutely.
6.5.
2006.5. Absolutely perfect, Janvi and Dikshita. Okay, so now the thing you have to draw a third column named deviation taken from 2006.5. Deviation taken from 2006.5. Okay, now 2004 minus 2006.5 is minus 2.5. 2005 minus 2006.5 is minus 1.5. And similarly, you will have all the values, means all the points of this column. As we did it earlier, since all these deviations are in form of points, minus 2.5, minus 1.5. And if you just proceed it with even this second degree parabola, if that point is there, it will be little more time consuming. So make it a full value. You are going to double it up. So deviation is being multiplied by 2 and now title it as x. So it is minus 5, minus 3, minus 2, sorry, minus 1, 1, 3 and 5. Ultimately, summation of x goes to 0. As you have calculated summation of second column, which is summation of y, which is 848. Now, the second degree parabola trend, or you can say the standard form of a second degree parabola, is y is equal to a plus bx plus cx squared. And we have to generate 3 different equations out of it. The first equation you may generate it by simply substituting, or you can say applying summation both the sides. While applying summation both the side, it comes to summation of y, which is n times a plus b times summation of x plus c times summation of x squared. To get a second equation, now you have to apply summation of x both the side. And to get the third equation, we have to apply summation of x square both the sides. So you will have three different equations. Now from these three different equations, you will be able to know that what are the columns further required. Summation of y, that you have it. Summation of x, that you have it. Summation of x square is required. Whatever summation is required, that column is required for sure. So one of the column should be x square, x cube, x raised to 4, xy, and it is x squared y. This many different columns are required. So all the things are, you do have x and y. So to generate column of xy, x square y, summation x square, x cube, or x raised to 4 is not a much bigger task. Just do it and confirm it that you are getting summation of xy as 694. Are you getting summation of xy as 694?
Yes, sir.
Okay. Now
Yes, sir.
x
Yes,
square,
sir.
very nice. X square y,
Yes, sir.
very nice.
Yes, sir.
Now corresponding x square, x cube, and x raised to 4. Are you getting the same results?
Yes, sir.
That's great. Once you get all these values, naturally you have to substitute it in different equations. Different equation means those three equations which we have found just now. Naturally, here summation of x is 0, automatically summation of x cube will be tend towards 0. So your equation will be reduced, and from second equation you will get value of b directly as summation of x and summation of x cube, both of them goes to 0 right away. So you'll be able to get value of b from the second equation directly. What is the value of b?
9.914. That is.
Absolutely perfect, which is 9.914. Now you have already utilized equation number 2, so you will be having equation number 1 and equation number 3, in which if you substitute summation of x as 0 and summation of x cube as 0, that equation means both the equation will be reduced to two variables and it becomes a linear equation. If you just solve this two linear equation having variable a and c, you will get value of a as well as c. I can assume that all of you are very good at solving linear equation.
C is 0.4464.
Value of C is 0.4464. What is the value of A?
136.13.
136.125, or you can say 13, that is all fine. Once you get value of C, if you just substitute it in any one of those two equations, you will get value of A. 131.125, that is all fine, because it is precision should be up to at least 2 to 3 digit. So now you have all these three values A, B and C. Just put it in a standard form of the second degree parabola. So y is equal to 136.125, which is value of A, plus value of B 9.914 times x plus 0.4464 times x squared, and you have to write, whenever you write a trend line, at that time your origin should be reflected. In this case, your origin means a deviation from which you have taken the value, and that deviation was taken from 2006.5, and since it is a 0.5 is there, your x unit is half year, right? This becomes the second degree parabola of the given data set. Now the question was to estimate the value for 2011. Before of that, you should have a column, and that column should be tagged as trend value YC, which is 136.125 plus 9.914 times x plus 0.4464 times x squared. Just go on passing different values of x to get the respective year's trend value. If you just insert, or you can say substitute, x is equal to -5, you will have trend value for 2004. So value for 2004 is 97.715. Similarly, all of the value of x are to be substituted. You will have trend value of respective years 2004, 2006, 2007 up to 2009. Confirm it once you get all this value similarly as it is on the screen right now.
Yes, sir. Got it.
All of them?
Yes, sir.
Yes,
Fine.
sir.
Then you try to predict the trend value for 2011.
Completed, sir.
That's great. You have a better
Yes,
speed.
sir. Completed.
That's great. Can I assume that all of you have completed it?
Yes, sir.
That's great. I think you have a better speed. Let us shift to the next example. In short, what is the takeaway from this example? If even number of years are given to you as number of observation, then you will have two different year as a middle year, and you will have a midpoint you have to take a deviation from that midpoint and you have to proceed it similarly, even if it is a second degree parabola, right? Okay, fine. Now I want you to do it in a lesser time than that of the previous example, right? Company engaged in producing petrol filters have recorded the following sales in the past few years: 2005, 6, 7, 8, 9, 10, 11. Number of observations are
7.
there are 7. Since number is 7, you will be having a middle year. Middle year is 2008, so things are fine with us. Fit a second degree parabola by taking 2008 as an origin. It is exclusively given to you and you have to estimate the forecast, or you can say you have to forecast the cell for 2012. Come on, buckle up and hello.
Yes, sir.
Am I audible? There was some technical issue with my computer. It went off. So I have shifted to some other instrument right now. I'm not sure.
Light is not seen, sir.
Yeah, I understand. You have to give me 5 minutes. As such, something went wrong with my computer and it went off right now. Because as such, all the files are with my computer as such. But let me see what I can do right away. Most probably there would not be any issue, I suppose.
Yes, it is seen, sir.
Yes. Fine, but we are far away from the slide which we are using right now. It will take little time, please. You have a time to calculate. You can calculate. Was it the same one? Hello?
Yes, sir.
Okay,
Yes, sir.
fine, go ahead. First thing first, put it in a equation column format. Year, number of year given to you, 7, midpoint is 2008. Make a column as Y. Summation of Y is 210. Make a column of X. Since all the deviations are to be taken from 2008, so 2005 minus 2008 becomes minus 3, minus 2, minus 1, 0, 1, 2, 3. Ultimately, summation of X goes to 0. Next column is xy, x square. I have skipped here one of the column as x cube, as if your column x goes to 0, naturally summation of x cube always goes to 0. So we don't have to calculate it or to represent it now and then. Now let me know all of you are having the same value of the column xy, x square y, x square.
Total of XY 694.
Summation of xy is 694. I think there is some mistake.
Oh no, sir. I was
164.
answer of the previous one.
Okay.
XY
164.
In this case, summation of xy is 164. Summation of x square is 28. Summation of x raised to 4 is 196. And summation of x square y is 882. Let me know once you get all these values perfectly okay.
Yes, sir.
Okay. Since your summation of x is 0, we can get directly value of b from the second equation, and value of b is 5.857. Are you getting it?
Yes, sir.
Okay, and to get value of a and c, we have to solve first and third equation. The first and third equations are shown on the screen right now. Summation of y is n times a plus c times summation of x square. And summation of x square y is a summation x square plus c times summation of x raised to 4. All these values are already with you. You just try to generate two different equations, get it solved. You will get value of a and value of c. What are the values of A and C? What is the value of A?
28.
It is 28. Value of C?
0.5.
0.5. If you just substitute all these values in an equation, you will have that trend, second degree parabola trend equation. YC, you can say, y calculate. Y is equal to 28 plus 5.857 times x plus 0.5 times x squared. And in this case, your origin was 2008 and your X unit is 1 year. Right? Okay. Now you can have a column. You can tag is or title can be YC is equal to 28 plus 5.857 times X plus 0.5 times X squared. Make a title of that column, go on substituting different values of X in this equation and get a trend value corresponding to each of the year. Once you do it, the second question was to get to estimate the value for 2011. So in this case, your value of X is equal to 2012 minus the origin, which is 2008. So value of X is 4. In the given equation, if you just substitute value of X is equal to 4, you will have some value and that will be the estimated value for 2012, which is 59.429. Are you able to get this value as 59.429?
Got it, sir.
That's great. Every one of you are getting this value 59.429 right away.
Yes, sir.
That's great. Right, let us shift to the next slide now. Am I audible perfectly?
Sir.
Hmm.
Yes, sir.
Yes, sir. Estimated for 2012,
Yeah.
58.348 lakh hours.
Look, This is a simple calculation, if I am not mistaken, right? 28 plus 5.857 times x, value of x is 4, right? Similarly, plus it is 0.5, which is given, value of c is 0.5. And it is x squared. X is 4, so x squared is 16. Make it simplify and try to get the value, and there is nothing left in this case. So you have to just sum it up. Whatever may be the value, just check it twice, and if you are getting the same value both the times, I don't think there would be any issue. Right? Can we shift to the next level?
Yes, sir.
Okay. Sometimes they may give you directly that fit the equation of the form y is equal to a plus bx plus cx squared to the given data. The data is given in form of x and y. Your value of x is, instead of x in the form of year, it is directly 1, 2, 3, 4, 5. Right? In this case, what they did is they used a variable x and y directly. Y was okay, but instead of year, they have used the title x directly. So you can use another variable. That is all fine. Ultimately, there is no alteration in any of the format. All the things will remain same as it is. Just put it in a column form. Deviation, since number of observations are 5, just take deviation from the middle value is 3, so summation, we are naming it as t, so summation of t will go to 0 in this case. Now instead of x, we are using a word t.
Sir,
Yes,
for last answer for estimation of 2012, it was 58.348.
that is fine, I
Yes, sir.
understand.
58.348.
That is possible. As I said it in the last example, that you are likely to substitute value of x as 4. All other things are fixed, and simply just make some of the calculation left hand side, multiplication, and multiplication is to be done and summing it up. It is absolutely fine. Do it twice. In any case, if you are getting the same result, there is nothing to worry of. Are you getting all these values as a sum of the columns?
Yes, sir. Got it.
That's great. Let me shift to the next slide now. So in this equation, y is equal to a plus bt square, where your value of t is nothing but x minus 3. That is all fine. Ultimately, our intention is to get value of a, b, and c. Proceeding it in a similar way, are you getting value of B as 5.3,
Yes, sir.
value of C as 0.64,
Yes, sir. Got it.
and value of A as 32.92?
Yes, sir. Got it.
So the second degree equation becomes something like this. Y is equal to 32.92 plus 5.3 times it was T. As you know that what is T? T is x minus 3. Just substitute it. And it is 0.64 times t square, where value of t is x minus 3. So it is x minus 3 square. Now simplify it and make it the simplified version will be the final value. So ultimately the equation is 22.78 plus 1.46 times x plus 0.64 x squared.
Got it, sir.
That's great. All of you are getting the same values?
Yes, sir.
Yes, sir.
Yes, sir.
That's great. Good. Let us shift to the next one. Fit a parabolic trend y is equal to a plus bx plus cx square for the following data. Data set, number of observations, pi. It is in the form of year and output, lakh tons. Fine enough. Go ahead and try to make it as soon as you can. Focus on speed.
Got it, sir.
That's good.
Got it.
Very nice. Equation is y is a plus bx plus cx square. You will have three different equations by which you will get value of B as 5.3. Value of C is 0.64. What is the value of A you are getting?
Point. No. 32.92.
32.92 is value of A. So the equation comes to 32.92 plus 5.3 times x plus 0.64 times x square, and the origin is 2010. Since it is in the full value, so your x unit becomes 1 year. Now to get trend values for each of the respective year, make a column. Go on substituting different values of x in that case and get respective y trend values. Substitute x is equal to -2, you will get trend value for 2008. Getting the same values.
Yes, sir. Got it.
Okay.
Yes, sir.
Okay. All of you are getting the answers right away.
Yes, sir.
Yes, sir.
Okay. So here you can make a column and you can put all those values in the column. This was the last example for second degree parabola. Is there any problem till now?
No, sir.
Fine. The next topic we will be addressing it would be seasonal variations, or you can say seasonal. Is it okay with all of you?
Yes, sir.
So we'll start the next thing, next methods for seasonal variations in the next lecture. To measure the seasonal variation, there are 4 different methods, of which 2 of them are there in your syllabus this year. Third and fourth is not in your syllabus this year. Have respective examples for it. Right? If you have any question, the floor is open right now.
Sir, can you please repeat the slide number 134 and 135?
This is 134.
Done, sir.
And this is 135.
Done, sir. Thank you.
Okay. May I take your leave now?
Yes, sir.
Thank you. Thank you for your
Yes,
time.
sir. Thank you.
Yes.
Bye for now.
Thank you, sir.
Thank you, sir.